So hey guys, welcome to my channel. I am Satyam Tripathi, and today we're going to be discussing this problem grid paths, which is of CSES problem set. So let's look at the problem statement. So consider a n cross n grid whose squares may have traps. It is not allowed to move to a square with a trap. Your task is to calculate the number of paths from upper left square to the lower right square, and you can only move right or down. So the input format is like there will be a line, an integer n, and there will be n lines that contain n characters, which will tell us the n cross n grid. And we have to print the number of paths modulo 10 to the power 9 plus 7. So like here is an example. As you can see, there will be 3 paths. So let's look towards the approach of this problem. Okay, so first of all, we have an n cross n grid. So let me make an n cross n grid. Suppose this is a grid, and let's divide it into rows. So like this is our grid. Pardon for like by drawing. So this is our grid, and initially we are at this cell, and we can either go down or we can either go right. So like we have to reach till this position, and we have to tell how many number of ways are there that so that we can reach at this cell. Now we also have to remember that like if there is a asterisk sign in any cell, then we have to skip those paths. Like this is a valid path, this is also a valid path, but a path that will go through this, it will be an invalid path. We can't consider this path. So now let's look at the approach of this. So let's assume like I am at cell, let's say I comma j. So basically I can either move towards I plus 1 comma j, that is downwards, or I can move towards I comma j plus 1, that is towards the right cell. So only these two moves are allowed, and also I have to check at each position that if at any cell, that if let's say we have this grid ARR. So at any cell, if ARR I and j is, let's say, equal to asterisk sign, then simply we don't have to consider this part, or you can say that we can return 0. Else if we reach like this point, which is n minus 1 comma n minus 1, in that case we will return 1 because it is a valid path. So now let's move towards coding this approach. So as I always do, like I will start from the basic recursion, then we'll move towards top-down approach, and then finally we'll proceed towards the bottom-up approach. So first of all, let's define the scanner object. Now I'll take my input, that is n, which tells us the size of the grid. Now I'll be like taking an input string of n length. String is equals to receive dot next line. Now we'll be defining an character array of n cross n. So now let's take the input here. Okay, so now let's make the recursive function. Just int x comma int x comma int y, which tells us the x and y coordinate. This is our character array. So basically the first base case is that if x is equals to 0, sorry, if x is equals to r dot length minus 1, like the last row, and y is equals to the last column, which is ar dot length minus 1. In this case we will return 1 because it will be a valid path. uh, if like we exceed this if we exceed like the like the row number of rows or number of columns, then we'll simply return 0 because they won't be a valid path. And now if also if there is like an asterisk sign at that cell that we are currently in, then also we'll return 0 because it won't be a valid path. Now what I have to return, I actually have to return like we have to move down, so x plus 1 comma y and arr plus f, like it will return the number of this function will return the number of ways of moving down, and this function will return the number of ways of moving right. Okay, I forgot one thing actually. We also have to take like the mod, because the number of ways will be too much, so we'll have to take a modulo of this. So I'll take a mod here. Okay, so we have taken a mod here. Now I think everything is perfect. Now let's call the function here. So and the answer is supposed to be for 0 comma 0 and arr, and let's print this. So here is our answer. Now what's the issue here? Okay, so it's not static actually. Right, so now let's try and run it. So okay, I think, oh, I got it. So basically the problem is like if you use a scanner object in Java and you use next int, then you have to like there is a next line character after each int, so you have to like call next line for one time. Okay, so now let's try it. Right, so the answer is coming 3. So now we'll try to optimize it using a DP array. So as you can see that our each state actually depends upon two variables, that is x and y, like the row we are currently in and the column that we are currently in, and there is no third variable. So the minimum number of the minimum state will be x comma y. So I'll define a DP array here, and its size will be x plus like x and y. Sorry, we don't have x here, and minus 1 comma, sorry, n comma n. Okay, and I'll fill it with 0. Okay. So here we have our DP array with all the elements initialized to minus 1. So here we will now have to add the condition, like if DP of x and y is equals to like this. Okay, I'll also have to pass this int DP, and I'll have to pass it here, and I'll have to pass it here as well. Okay, so it's ready now. Only I need to add one more condition. DP x y is not equal to minus 1. Then we have already calculated that, so we will just return the DP x y. Now let's try this out. Okay, so it's also working. You can see here the output was 3 and this is the input, so it is working. So now let's move forward to our bottom-up approach. Okay, so now I'll be discussing the bottom-up approach for this problem. So before I discuss the bottom approach, I also want to like add another perspective to the problem. Like So and when we were using top-down approach, we were like assuming that we were here and we had to go till n minus one. Now there can also be like this that we are at currently this cell n minus one comma n minus one, and we are just doing the opposite. Like we have the when we were here, we had the moves like we could go down, or either we could go at the right cell. So here we can do just opposite. We can either go left or we can either go up. It is the same as like going down or going right from here to reach this, and when we are looking from this perspective, we have to reach 0 comma 0. So basically this is the top down approach, and now I'll be coding this. So first in this case, the base case will be when we will reach this cell tp 0 comma 0 cell. So like first of all I'll be assigning the base case to it, which is 1. Now I'll be traversing making this loop for the rows, and this is the loop for the columns. Now first of all, if this cell contains an asterisk character, then we'll simply return assign dpij is equals to 0 and just return continue. So I just do dpij is equals to 0 and I just simply continue. Okay. If now I'll check, I'll have to check a cell that is just before this cell. So what I'll do, if I minus 1 is greater than equal to 0, because it should be in the range of rows, so then I'll have to dpij plus is equals to dpi minus 1 j, because it is a possible way. So I'll add the move of going up to the current state of the dp. Else we can do same, like we have to go left, so we'll check for this also. dpij plus is equals to dpi comma j minus 1. So it's ready now. I think it should give a proper answer now. So I enter dp n minus 1, because since we are starting from n minus 1, so our answer will be contained in this coordinates of the dp. So let's print it now. Okay, we don't have forgot to add the modulus. I'll do that also. Right, so here we are mod, here also mod, and outside we can do dpij equals to mod. Okay, so it's ready now. Now let's try it. Okay, it's working. So let's try and submit it. There's some problem, I think. Wait a minute. Okay, so there was some problem from my end. So now let's try and submit it. This. I forgot the folder name here. It is. Okay, submit it. Okay, so here our solution is accepted. So if you got to learn something from this video, do drop a like, and also if you have any queries, you can just comment there and I'll try to respond as soon as possible. Thank you.